Okay, so this one, I think I did explain this part from last time. Yeah, you need civilian emperor slave. Each player gets 5 cards. Remaining one is either emperor or slave. Round ends when the emperor slave is played. And then you also have the millimeters. And then you only win 100,000 yen if you're the emperor side, but it is quintupled when you're in the slave side. So let's go through that. So, of course, we need to use vector. We also need to use our string. And then let's just include, using namespace std. So, first off, what we can do is yung itong part, the code restriction. No, so let's do the code restriction first. Kasi nandyan na siya eh. So we have int round is equal to 1, int left is equal to 30, int money earned is 0. You have a while loop, and then you have play round money earned left. So feel free to interrupt me, especially if you can't hear me, kasi I can't see I can't see the Discord. Tapos dulo round plus plus, and then return 0. Okay, so we need a while loop. It has to keep on looping until certain criteria. So what is that criteria? If you read through this one, so here, the twist is that the game ends in 12 rounds. That's one. Another thing is, ito pala. The game will only end if and only if the 12 rounds are finished or the contraption has already pierced Kaiji's eardrum. Which means we will keep on repeating this when the left is more than 0, meaning there's still left, and the round is less than or equal to 12. So what does this mean? If the left reaches 0, this will be false, because 0 is not greater than 0. If round is maybe, let's say, 2 or 3, that's true. So false and true is false. If you remember the AND operator, if it's true, it'll be true. If it's true, false, it'll be false. If it's false, true, it'll be false. And then if it's false, false, it'll be false. So if one of this is broken, we will stop playing. Okay? So let's create also a playground. Void playground. This uses int round, int money earned, and int left. But I want to use const and reference. First, round. The round, based on this, we are only changing the round here in the main. That means we're not supposed to change it here inside the playground. So that will be constant int ampersand. Int money earned will probably change in here. So we have int ampersand money earned. And then same thing with left. We are probably going to change it here. Left. Int ampersand left. There. Now, the thing is, let's do the endings. There are 3 endings. So what we're doing is yung madalang part. If the best ending is he has the left is still more than 0, and he also reached his 20 million yen goal. So we have that one. So let's just put it here muna. If left is greater than 0 and money earned is greater than or equal to 20 million. Is right. 120. 20. So that's one. So I'm just putting this muna. Yung may ending is left is still greater than 0, but the money earned is less than 20 million. And finally, the last one is if left is less than or equal to 0. So you can make it to equal to 0, or you can make it less than or equal to 0. Both are fine. Okay, so how can we make this instead of multiple ifs? We can try to do something here. Una, if he has no more left and he still has money, it should always be a lose. Kahit na he has already 20 million, he should lose. So that's the very top. Bad ending. Next, this means if you have if left here is less than or equal to 0, that means if you have a else here, else something, we can say left is already more than 0. So else if we can go straight to money earned is greater than or equal to 20 million. So why did we skip this? It's because we already said that the left is already more than 0 because we have this here. So anything else with the else here, left is greater than 0 na. So if it is more than, we can say a good ending. That means if it's a else here, the money earned is less than 20 million, and left is still greater than 0. So we have here meh ending. Okay? So those are our endings. Okay? So we have the endings here. Let's check here. Endings. We're done with that. Yun pa lang. Okay. So now let's go to the cards. Sabi niya, you'll have a 4 civilians and then either emperor or slave. So there are 2 ways into doing this. Wait lang. Let me just check first. You must be able to output either slave deck or emperor deck. Okay. So that means I want to create a vector of string. So I want it to return create cards. So this is where things get different. I could either use boolean if like is emperor, right? So if it's true, that means it is emperor. If it's false, it's slave. I can also use string, like it'll be the name of the emperor or slave. So for now, I want bool is emperor. So this part, I like to use const int. Const string, especially when you have something like to use a string called civilian, a string of emperor, a string of slave. So I would like to create a global variable. So I'm pretty sure people, in BASPRG2, they taught you should not use global variable, right? You can use global variable, but for specific reasons. Especially if it's just a constant you're gonna use everywhere. So I can have like a const string civilian card. So this will just be civilian. I can have a const string emperor card equals to emperor. I can also have a const string slave card slave. So this way, if I accidentally misspell it, right, at some point, something's gonna go wrong. At least here, since it will always just be either civilian, emperor, slave of a string, I can just make a const. So now, we create our vector string, deck. And what I want is at the very top will be either emperor or slave. You can also choose to make it the very bottom. Both work fine. In this case, deck dot pushback. So this is a bit advanced. Something that you may not know is emperor question mark. So what this does is this question mark will try to say if it's true or false. On the left side, it will be emperor card. On the right side is the slave card. So what does this mean? It just means that if this is true, it will follow this one. If this is false, it will follow the one on the right. If you don't get this, it is literally just like this. String card. If is emperor card is equal to emperor card. Else card is equal to slave card. And then you would have deck.pushback card. So this whole thing is literally just this. Both are okay. If you are used to this, it's fine. If you want to make it a bit shorter, you can use this. So this is medyo advanced. So if you want, let's not use this muna para gets nyo pa. And then we have the 4 civilian cards. So we just use a int. For int I is equal to 0, I is less than 4, I plus plus. Oops. We have deck.pushback the civilian card. So it will push it back 4 times. And finally, return deck. So that is my create card. We create deck. Gets nyo pa to? So I just get if it's emperor, I use the emperor card. If it's not emperor, I use the slave card. And then we have the cards at the deck. So we now have create deck card. When a card is played, it must be removed from the deck. So we can do that later. That's a good one. This one. Write a function represents the list of card to choose from. Return the chosen card as the function output. That plus we have this saan yun? Detailed user feedback. They're almost the same thing. We need to show the cards pa rin. So let's show all the cards. Oh, by the way, we can do const reference. So let's show all the cards. Void print deck. Of course, we have the vector, string, deck, and then since we're not gonna manipulate it or change anything, we can make it a const. You can also have a ampersand here. Okay, so we just have to print it out. For int I is equal to 0, I is less than deck dot size I plus plus. So I want the very first to be 1. So count I plus 1. So that will be the number 1. And then we can put the dot. And then the card. Deck. Deck. Oh, sorry. Tama ba to? Deck. Oh, ano ba ginagawa ko? Hold on. Yeah. Deck. I think we use deck dot begin plus I. This is right? Parang hindi. At. Right, I can use at. Can I? wait. You know what? I think that's fine. Let's test it out. Test out muna natin yan. So let's just put a vector. And we're just testing this out. String deck is equal to create cards true, and then print cards. Print deck, and then return 0. Emperor's 7777. Okay, tama. I am just missing the handle. So there, we have our deck, our printing. Kuha pa naman. Questions so far? No questions? Sige. So, what else we need? Our printing play card. Okay, let's play the card. So, if we're gonna play the card, we have to first void player turn. We need the deck. I know, actually, maybe better. String, and then player get card. And then we have our const vector string our deck. So of course count. No, let's print muna. Print deck, and then count, select a card, select the number of a card. Then int choice is equal to 0. So we can do a while loop here so that the choice should be within 1 or whatever the size of the deck is. Do while choice is less than or equal to 0, or choice is greater than deck.size. So meaning if the choice is 0 or -1, we have to repeat it. We don't want them to select it. Or if the choice is more than a deck size, so let's say if it's 1 to 5, because there are 5 in the deck, and they choose 6 or 7, we want to repeat it again. So sin choice. There. So we have a choice. We can now deck dot right. We can already do the deletion here. So let's just remove const. Deck dot erase from deck dot begin plus choice -1. Why choice -1? Because remember, we started at 1, 2, 3, 4, 5, not 0, 1, 2, 3, 4. So we want to minus it, right? Kasi hero, nag+1 tayo. So we want to minus it. So, wait, before we erase it, we get the string. Card is equal to deck dot at choice -1, and then return card. So we erased it. So same thing with the enemy. String enemy AI. Again, vector of string ampersand deck. Almost the same thing, but we can immediately select the index. So int AI choice is equal to rand ampersand deck.size. So you have a string choice card is equal to deck.at AI choice, and then remember we need to erase it. So deck erase deck dot begin plus AI choice, and finally we return their card. There. So now we have the player who will select the card, AI will select their card. So we have that game part. But of course we need to do the betting. We need to do the bet part. Where is that? Wager. Void wager. We have the const int left. So maybe we can do an int here. Let's return the whatever they chose. Int choice is equal to 0. While choice is less than or equal to 0, or choice is greater than left. So we keep on repeating it until they've chosen between 1 or between 1 and left. So again, count to wager. and then sin choice, and finally return choice. So that's our wager. So we have wager, we have the card. Yeah, so that muna. So let's do that. First, the player needs to wager. Left. We need to get the amount. So int wager amount. So that's okay. Next, we need to get the card that the player chose. So string player choice is equal to player get card. Player get card. Alright, our deck. We need to create our deck first. String vector string player deck is equal to create cards. So what is this boolean? How do we do this boolean? So there are different ways to do this. You can create an array or something, or for me, I can create a bool. Bool is emperor. It's equal to, so if it's rounds 1, 2, 3, 4, 5, 6, 7, 8, 9. So round percent 6 is less than 3. What does this mean? So if round 1, 1 is less than 3, true. Round 2, 2 is less than 3, true. 3 ampersand 6 is less than 3, no. So let's make it less than equal to. Okay. 4 is 4 ampersand 6 less than 3, no. So that is false na. 5 is 5 ampersand 6 less than 3, no. 6 is 6 ampersand 6 6 and modulo 6. Sorry, I was using the wrong term. 6 modulo 6 is 0. So there's something wrong. I'll put a -1 here since we start at round 1, and I think we can do that. Okay, again, round 1, 1 minus 1 is equal to 0. 0 ampersand 6 is ampersand modulo. Is 0 less than 3? Yes. 1 less than 3? Yes. 2 less than 3? Yes. 3 less than 3? No. 4 less than 3? No. 5 less than 3? No. When you come to round 6, round 7, so 7 minus 1, 6. 6 modulo 6 is 0. So back at it again. So it'll be on rounds 1, 2, 3, and 7, 8, 9. Okay. I hope you got that one. There are different ways. Okay lang rin yung may list kayo of, array of true to true, false to false, or something like that. Kinda okay. Yun lang you're kinda strict, stuck to that. You'll have to modify it if you wanna change something. Okay, so we're almost there. So player deck, this one creates the emperor if round 1. Vector string enemy deck, this creates the, if ever, the slave. So not is emperor. So if this is true, this should be false. If this is false, this should be true. Now we have to repeat this X amount of times until they chose either emperor or slave. So what I will do, make this empty. Oh shoot, sorry. Enemy choice equal to. So what I will do is do while player choice is equal to enemy choice. So what does this mean? There is no way that the player and enemy would have an emperor at the same time. It's either they have emperor civilian or slave civilian. So the moment they play an emperor or a slave, this will automatically be false. But if they play civilian, it's true. They can go to the next next card. So player choice is equal to get player get card. We have player deck, and then we also have enemy choice. Enemy choice equal to enemy AI, and then we have their deck, enemy deck. Now this is the part where we have to compare, evaluate matchup. So if player choice is equal to emperor card and enemy choice is equal to civilian card, so this is a normal win. What else do we have? If player choice is equal to civilian card and enemy choice is equal to slave card, that's a normal win. If if player choice is equal to slave card and enemy choice is equal to emperor card, this is where they get times 5, right? So this is the 3. So let's put it together. Remember, this will just give the same thing. Yeah, they give the same thing. So what I can do, I can just put that in here. Or. So it's an or because if it's either this or this, they will win the bet normally. So like money earned plus equals 100,000 times the wager amount. So we can remove this. Else if this one they earn 5 times, so money earned plus equals to 500,000 times the wager amount. Else if he doesn't win any of those, he loses, right? So left minus equals wager amount. So now we have that. Play around, to choose the card, and if wait. sorry. We should have else if here. Else if it's the same, player choice is equal to enemy choice, it's a draw. Nothing happens. So we count draw and L. So this one, if you want to put let's just put count here na lang. Count sige, lagay natin sa int money 1 is equal to this money 1, and then we can put a count player 1 money 1. So what's happening here? So same thing. I think I want to do this as well for the emperor. Int money 1 is equal to money 1 count player 1 money 1. Else if there is a draw, and then they just do it again. Else they lost someone. Natalo si player, then left is minus. Okay. Let's put the count here. Count. Player played. Player choice. Enemy played. Enemy choice. Okay, I think that's it. Did we use everything? Wager, player get card. Well, count. Your eardrum has been pierced. You won your goal. You saved your eardrum, but you did not reach your goal. Okay, tingnan natin kung tama, kung gana ba to. I should put a count. I wanna show the details. Count. Round. Money earned. Money earned. Wait, enter. Left. Left. And then let's put a pause. System. Let's put a pause, and also a system CLS. There we go. All right, round 1. Left. Round 1, 10. I want to play Emperor. So I win. What is that? 1, 2, 3. 1, 2. 1, 2, 3. 1, 2, 3. What am I missing? Why don't you win 100,000? 1, 2, 3. What happened? I wagered 10. Wager left. One, two, three. 1, 2, 3. Yeah, tama. Sorry. Yeah, that's right. So if I do 30, Emperor Slave, I win 300,000. 3 million. 1, 2, 3, 1. Yeah, 3 million. And then let's say another 10. Okay. And then this one, I should have put either I'm Emperor or Slave, so that I know that I should be waging less. He played civilian. I played civilian. He played Emperor. I lose. I should put a count there. You lost. Wager amount decreased from the device. Okay, so yeah, this is the game. So this is the outcome. Then in here, in the player round, we create the cards first. We get the wager amount, and then we have a while loop. This while loop it will keep on looping if they're equal, the player choice and the enemy choice. So it will keep looping that one. That means, because again, either one of them is either emperor or slave. There's no way that both of them have emperor, both of them have slave. So if they play civilian, nothing happens. Draw. Okay. Questions? Was that too fast? Wager gets na naman to. If as long as it is above 1 and below the left, it will keep on repeating. But if you broke that, if it's above 1 and below or equal to left, it will not repeat. But if it's an invalid choice, it will keep repeating. So same thing here. As long as the choice is less than or equal to 0, that is because I started at 1, right? Or it is more than the deck size, meaning it is more, let's say there are 5, he chose 6. So di pwede yun. So it will keep repeating until he finally chose 1. Then he erases it, he picks it up, he erases it, and then we return that string. So if you try to, let's say, do civilian, there, it's removing. And then he's gonna play slave. Oh no, okay. Alright, questions, clarification? Sorry, more than 30 minutes pala. Okay lang, medyo madali naman yung next topic. And wala namang homework. Questions, clarification? Maybe like you have a question, why use boolean? Honestly, there's no difference. You can use boolean, you can use string. You just have to know. I think that's what the others did. Instead of boolean, they use string here, and then they have a vector of string, and then turn order. You have emperor, oops, and then slave, etc. Ito inilalagay nila dito. And dito, they have like a if else. If it is emperor, you do slave. If it's slave, you do emperor. So that's the other way. Okay? So that's how you do this. So no questions? I hope you get this one. This one, you just have to find out, no? Paano yung ginagawa. So 1, 2, 3, di pwede. 1, 2, 3, emperor. 7, 8, 9, emperor. So, ito yung Ito yung how it looks like. Either this or this one. They're both okay. So no questions? We can go ahead to pointers. So I hope this wasn't too fast for you. I hope nag-gets nyo naman to. If not, that's okay. You can just message me. Maybe you want me to explain something. Okay, that's fine. We can talk about it. There's nothing wrong. Alright, so sige. So there's no questions, we can go to our pointer as reference. So this one, I'm not gonna be able to see your message. So in any case, try to either play a soundboard if you have a question or not, because I'm not gonna be able to keep alt-tabbing. Nakakahilo rin sa inyo yun. So just play a soundboard if you have a question. Okay, so pointer as reference. A pointer is a variable which stores a memory address, just like a reference. So they're the same thing. It stores the memory address and not the value. But the thing is, when a pointer is assigned, it only copies the memory address. The object itself is not duplicated. So the thing is, they're not the same as reference. Reference, you can't even assign another address to a reference. Parang isa lang yun. So I'll get to that. So the memory address is not hidden to the programmer, unlike reference. So with pointers, you're actually able to print out where the actual address is for this pointer. And I'll show you that later. By reference, you're not really able to. You can only print out the value, but not the actual memory. How is it useful? Not really useful. You're not gonna ever use the actual memory address. It's just something good to know. Right. Next, multiple pointers can point to the same object. So again, not like reference. Reference, you can't point multiple things. Parang one-to-one lang talaga siya. We can't give a reference to another reference. Di yun pwede. No matter how you try it out, di siya pwede. But pointers though, you can have multiple pointers referencing one memory address or one object. So put it simply, reference gives us more control over the memory address. Okay. So how do you set up a pointer? So the pointer, unlike ampersand, you use the asterisk. So we suffix the data type with an asterisk to declare a pointer variable. So this can only be assigned with a variable of the same data type. So you're not able to create a pointer to an int and then you're gonna point it to a memory address of a float. Di pwede yun. Di niya tatanggapin. They both have to have the same data type. So if it's int pointer, it should point to an address that is also an int. Okay. So unlike referencing, we have to assign an actual memory address. So to do this, we extract the memory address of a variable using the ampersand operator. So it's like reference. We use the reference to point on an address, right? So same thing. So if you want to point the pointer to the address of a int or something, you use the ampersand operator. So it's very similar to how we set up a reference, but there's more manual work. You can't simply just in ampersand value is equal to 10. Hindi pwede. We need to first create a variable so that we can actually point it to that address of that variable. Questions? None. Okay. Pointer assignment and null pointer. So, has anyone ever encountered the null pointer? Or what does null mean? Anyone? No value, correct. So null means there's no value to it. So same thing, but different name. We use null pointer. This means it is literally nothing. So initially, the default value of all pointers is a null pointer. Only until you assign it to an address, then it is not a null pointer, but the address of whatever you chose. So pointers can be reassigned to another object. So that's something new. So if you see here, I'm able to assign value pointer to the address of the value, and later on I can point the value pointer to the address of other value. So doing that, I'm now accessing the address of other value na. I have no connection to the value here anymore. Questions? Okay, so again, pointers initially are just null pointers, nothing. Now, understanding memory address. So this part medyo technical na to. So imagine each box represents 1 byte of memory. A float takes up 4 blocks because it takes up 4 bytes. Right, you can search that. Float is 4, I think double is 8. I think. I can't recall. Okay, so any value type variable is assigned a memory address, like see this 512 upon declaration. So you see, it only, sure, it uses 4 bytes. A variable uses 4 bytes, but it only stores the very first byte on where it is. Or sorry, the very first address of the byte. So a pointer stores a memory address value, the var float pointer, and it stores that address, the 512. So this can be used to access reference an object, which is var float. So a null pointer is just a pointer with a value of 0. All right. So it's just pointing. It's just pointing to the very first, the very first address of the variable's memory. That's all it does. So I'm not hearing any soundboard. Okay, sorry. Yes. So again, the asterisk means it's a pointer. It is trying to point to a memory address. So here, this one. So this one, it is trying to point to a memory address. In this case, value pointer is pointing to the address of value. So we need to use ampersand to access the address of the variable. So that's all it does. So it is, you have more control of this. You can't do this with reference. If you have an int ampersand value pointer is equal to value, you're not going to be able to change it to something else. You cannot do this. You cannot do this at all. So yun yung pagka-unique niya. So the asterisk looks like a point. I don't know. No. Okay. So pointer is really just a memory address. Yes. Right. So you'll see here, if you try to, so value is equal to 10, you'll see, if you print it out, value is equal to 10. Then here, we pointed the value pointer to the address of value. So if you try to print this, the return of it is literally the address 006FFB those are 4 bytes. No, sorry, that is the address, sorry, not 4 bytes. And the same thing here, if you try to make it a null pointer, if you try to access its value, it is 000 because null pointer again is an address of 0. Questions? Clarification so far? None. So memory address is actually common. So if it's just a memory address, how do we access the actual value? So you saw a while ago how to access the address. How is it useful? Not really. But what we want is the actual value. In order to access the actual value, we have to dereference it. Same thing like when you learn a reference, remember we have to use the ampersand to dereference or something. The same thing. It's literally the same idea. So we have the pointer. Oh, sorry. Points to the box of the data. This is the reference. Yeah. So we can have multiple pointers pointing to the same address, or in this case, this PS4. So once you have access to the box, you can fiddle its contents. We can dereference it and get the actual object. So how we did that in referencing, remember you used the ampersand. Yeah. Ayan. So in this case, for here, you have the value pointer. But here, in order to access the actual value, you dereference it by using, again, another asterisk. So the moment you put an asterisk to on a pointer, you dereference it to the actual value, which is 10. So if you see here, value pointer is pointing to the address of value. So I dereference it here with the asterisk, we end up getting 10. And same thing here. We have an ampersand, value pointer is equal to 500. We are modifying the value. We are modifying this because the moment you dereference it, you are pointing to the actual the memory address of this. So if you change it, this changes as well. So again, if you have a pointer, if you want to change its value, put the asterisk. So this only works for itong mga base, not, you don't call it base. Itong mga int, float, double, right? Iba na yung kapag ano, if you use classes or structs, that's different. So this is only good for yung mga int or float, decimal, long, okay? String, yeah, string works. Yeah. Question? Clarification? None? Di naman? Wala naman? Wow. Joke lang. So array is literally just a pointer. Kasi an array, it combines different addresses and puts it into that array, whatever. So an array is just a pointer to the first index. So arrays are tightly compact sequential blocks. They are connected together. So with fixed memory address offset based on the data type. So if you started with the very first one, 501, and then you have an array of 8, it creates the space for this amount. That's why you, in most cases, I mean here, that's why we always try to say what the size of the array is. You can't simply just make it an empty. Here, at least in C++, you can't just make a short array tapos open close bracket. Hindi pwede. The reason why is because we make the program make the space first. That's why you have to tell what is the size of the array, right? So we can shift from the first index to any index through the pointer arithmetic. Uh, if you think about this, parang siyang vector, no? The way we use begin. That's why when you erase, it's like erase tapos something that begin plus something. Kasi parang siyang the same, parang siyang pares lang. We need the very first uh, index where iterator, wherever that is. No. So anyway, adding an integer to a pointer shifts or offsets the pointer by the size of the data type. So yun nga, parang plus 0, plus 1, plus 2, plus 3. So the first pointer is literally the address of the array. So we can use increment operator to quickly shift by one index. Yeah, when you do the for loop, that's why you use I++. Okay, questions? Oh, is this why iris expire when pushed through a function's parameter? Yes. I forgot if I tried it or not. Yeah, I haven't tried it. No, I did try it. It won't allow you to reference an array, no? It tells you to make a pointer. If you try that out at some point, no? You can't just simply reference it, eh? Or I think or const something one of those. I kind of forgot. But yeah, you won't be able to get the size of an array once you pass it to a function. There's a way. Use a function called size of. So I think that it's here. Or here, size of. So you're kind of able to get it. It's just that you have to find a way, no? So yeah, here. So like we showed a while ago. Remember it's like an array is a pointer. So if you say short asterisk first pointer is equal to short array, we got the very first address. Hence, if you try to just do arithmetic, the first pointer plus 1, first pointer plus 2, you will end up getting the actual values. So if you remove the asterisk, of course, it's all just mumbo jumbo. It's all just the addresses. So that's why asterisk and then first pointer plus I. Because you're like going through all the elements. So this is another way also, asterisk first pointer, and then you're able to increment the pointer. So first pointer plus plus. So same thing. Ayun. Well, you'll learn something. Size of. You can use this. Okay, questions here about the pointer. So this could be useful for some. It's sometimes a rare reason why to use this, but it's something good to know as well, that the array is literally just a pointer to the very first address. No questions? Okay, lapit na. So, hindi pala. Wait lang ah. Ano nangyari dito? Size of array. What happened here? Here. We're here. So, int random array. Since the size of the original size represents all elements. 80. Print array random array. What happened here? Size of. Okay. Sorry. My bad. Yeah, you're right. Yeah, you can't use pala size of. It's not the size of the array, but the actual size, as in bytes. My bad. So since an original array only represents all the elements, so the size of all of this is 80 because there are 20 elements times 4 bytes for each element. That's 80. However, when you try to print the random array, this one, you're only copying the first element. It's a pointer, remember? It's just a pointer. So if you try to do the size of, it only got the very first uh, element or pointer to the whole array. Alright, so these are two different things. This one kasi you're passing this random array into here, which is just, again, just pointing to the very first address. Kaya 4. 4 lang yung size niya. So if you print it out, same thing. It should be okay. So when error passes the parent function, only the memory address of the first index is passed. Isipin nyo rin is like parang siyang C++ is trying to save you memory. Kasi if you have multiple like that, it'll be medyo malaki. Imagine you have an array of 100, tapos yung parating mo sinesend every frame or every millisecond. So you have like 400 bytes coming through multiple times. Yeah, ayun. So it just sends the very first index. Okay, questions, clarification? None? Okay. So points to pointer. Should I forget about the reference since we have pointers now? No. No. Because you can't replace everything to a pointer. Just like a while ago, we're able to use const. Const ampersand. That saves quite a lot. It's just like pointers, pero you don't have to. You don't have to switch up right away. So when should I use a reference? When should I use a pointer? So that depends on you guys. Depending if you want to use the same variable multiple times for different variables. So this depends. Right now, it doesn't make sense in doing so. But when you come to learning about structs and classes, then it makes sense. So is there any significance in having access to the memory address? Should I use pointers for defining arrays? So memory address, I don't really see any reason to use a memory address to print it out. Sure, you can use it to reference, but would you use it anywhere else besides referencing? Maybe not. So to use pointers for defining arrays? I would say no. For me, no. Because it's much neater. It's much neater to see a int array something x amount of like whatever yung size. I'd rather much see that than just a pointer and then you're doing pointer plus plus. Parang for me nakalito siya. But that's just me. Maybe it could be subjective for you guys, you know. But yeah, that's it for pointers. So try to review this next time before next week. Next week kasi we're gonna talk about pointers still, but we're gonna have we're gonna use classes and structs. Yeah. Questions? Clarification of anything here? None at the moment. None? Okay. So yeah. Yun lang naman for today. I hope you learned a bit about pointers. Try to review it before next week. We're gonna talk about it again. Baka kasi malimutan nyo next week. And then, mawala kayo sa, sa buong lesson, no? So, try to review this before next week. And, yeah, there's no homework for today. Next week, we'll have a homework. That homework will be related, of course, to pointers. You're gonna have to use whatever you learned today and also next week for that homework. But yeah, no homework for this week. So everything is good. So again, please just communicate. Message me. Message me if you're having problems. Message me if you need help. Sure, I don't mind. Okay? So yeah, that's it for today. You guys can go. Then I will be seeing you guys next week. And I hope you have a great week. Well, bukas na lang yung classes nyo. Unless may Saturday classes. No, may classes ba Saturday? Can't recall. But yeah, baka hanggang bukas ang classes nyo. But yeah, I hope you guys have a great weekend. I'll be seeing you guys next week. Alright, bye-bye. Ingat kayo.